Okay, so we're looking for x and y intercepts of the graph of the function. So the function is this parabola right here. And so an x-intercept is where the function intercepts or hits the x-axis. So the x-intercepts are going to be at 1 and 3. All right. And then the y-intercept is where this thing hits the y-axis. So y-intercept will be at 3 as well. And that's all you got to do. And then you move on. It's pretty cool. All right, on this one, we're determining whether or not something is a function. You always have your x values on the left in the domain, and your y values are on the right in the range. Okay, so for something to be a function, you can't use an x value more than once. Notice this x value links to -7, and that's it. This one links to -6, and that's it. G links to -7, and that's it. U links to -3, and that's it. So this one is a function. Yeah, -7 gets used more than once, but I don't care. For something to be a function, the x values have to each be used once and no more. Okay. The second one over here is not a function because y is being used twice. It's going to h and it's also going to b. And that's the only reason this guy is not a function. How about this guy? Number 3. Number 3, m is used once, and z and y and e and a. Each one is used once. Yeah, cloud gets used repeatedly, but so what? The answer is yes, it is a function. Down here, not a function because -3 gets used more than once in the domain. And then, oh yeah, it gets used 3 times. And -5 gets used more than once, which even if I didn't have that, it still wouldn't be a function. So no, not a function. On this one, we're determining if these things are functions, but now it's visually. So we use what's called the vertical line test. Okay. If a vertical line hits the graph of the relation more than once, it's not a function. So, and it just takes one vertical line to break the deal. So on this one, there is no single vertical line that will hit the function more than one time. So the answer is yes, it is a function. Okay. Same thing on this one, on the second one. Doesn't matter what vertical line I draw, it will hit the graph at most one time. So it's a function. But this one, oh, how could you? There is at least one vertical line that will hit this more than once. Heck, the y-axis, that'll do it, or over here. And so, yeah, this vertical line hits it more than one time. So it's not a function. Now let's think about, what that means. Okay, for example, when x is 4, there's this point here called, that looks like about 4, 3.5, 4, 3.5, roughly. It doesn't matter if I'm exact on this one. And then down here, looks like about 4, -1. Okay. Hey, look, there's an x value that's being used more than once. That's why it's not a function. Okay, that's why the vertical line test works, because the vertical line test is doing what we did on that last topic, but visually. Okay. This one would not be a function. I can find a vertical line that hits it more than once, including the y-axis. So no. This one here, well, the y-axis is hitting it twice. So no, it's not a function. And clearly, you can find a vertical line that hits this thing more than once. So no, not a function. That's how we do it. Okay, so now we're going to learn the basics of evaluating functions. So this right here says, go to the f function, okay, which is this guy here, and plug in 3/2 for x. Or in other words, and this is important to remember and to keep in mind. In other words, this means when x is 3/2, what's y in the f function? When x is -4, what's y? In the g function. When x is 2, what's y? In the h function. So you plug in an x, and the function spits out a y value. All right, so let's see what we got here. So I'll go f of 3/2 equals absolute value of 6 times 3/2 minus 11. So f of 3/2 means go to the f function, replace the x with 3/2. All right, well, I can cancel the 2's, and I get 9 minus 11, which is -2, which is 2. So if I graph this function, when x is 3/2, y is +2. I wonder what that would look like on the old calculator. Let's take a look. Okay, so if I plug in the original function, so I need to get I'm on the y equals menu. So if I go math, right, enter, I get absolute value. And then I'll go 6x minus 11. And that was the function in the absolute value. Okay, and then, for example, if I go, no, not there, I want to go to the graph, I guess. So if I go to the graph, I'm right there, that's cool. And I was curious about what was going on when x is 3/2. Well, if I hit the trace button, and I go to 3/2 for x, which means 1.5, I'm looking at those x values. You know what, maybe I should clear out the screen a little, make this easier. Okay, so I go to 1.5. And this isn't going to be exactly 1.5. Well, that's pretty darn close. So I'm really close to 1.5, 3/2. And look at that, my y value is really close to 2. I could go second trace, and then option 1 is value, and then I can type in 3/2, and then I get exactly 2. Or I could go second window, go to ask, and then on the window say, all right, 1.5 or 3 divided by 2. And yeah, you get exactly 2. So yeah, when x is 3/2, y is 2. That's what that means. All right, let's go back to here. So what about g of -4? Well, that says in the g function, when x is -3 or -4, what is y? And it's a good thing to do whenever you're plugging numbers into a function. Put parentheses around those numbers you're plugging in. Sometimes it'll be overkill. It will never be wrong though, and it will help you to get the right answers. All right, -4. Oh, wait a minute. There's no negative on the exponent. Sorry about that. -4 to the 3rd power is -64. Both times. And we get -62 over -64. Cancel the 2's, and I get -31 over 32. And ta-da, we're done. Okay, let's do the last one. All right, h of 2. So we'll go to the h function, replace the x with 2, and it doesn't really simplify any further, so that looks pretty good. Yeah, that's how we do it. Okay, so now we've got a couple of functions, and we want to know. We're going to do the same thing. Okay, there's variables we're plugging in and blah blah blah, but who cares? Whatever's inside the parentheses, you plug it in for x. So don't get all confused on it. So so the first one says, for the f function, replace all of your x's with 5 over x. All right, so do it. So my answer is still going to have an x in it, and that's okay. Nothing wrong with that. Oh, I don't know why I put that f down there. That was unnecessary. Let me get rid of that. Okay. So now it's mainly just to algebra problem or that has nothing to do with functions for the most part. So I'll get 30 over x plus 2, 20 over x plus 3. And just like we've done in the past, other math classes, we got to multiply by x over x and x over x so we can get common denominators. Okay. So that'll be 30 over x plus 2x over x, 20 over x plus 3x over x. Okay. Which is going to be 30 plus 2x over x, all of that over 20 plus 30x over x. Running out of room. Okay, so let's go like this. I'll just go back here. You can rewind the tape if you need to. Yeah, I know. Very much from the 20th century. Okay, so then, so we got a fraction divided by a fraction. Well, that just means, oh, whoops, I'm gonna click there. That just means that we're gonna have, what color do I wanna do? Let's go this one. That I'm gonna have the first fraction, or the top fraction, multiplied, and I'm not going to use an x because I'm already using that as a variable, and I don't want to accidentally confuse things. Multiplied by the reciprocal of the bottom fraction. Okay. So we got all of that. And now that it's multiplication, we can proceed and we can say, hey, these x's cancel. That's pretty cool. And I'm left with 30 plus 2x over 20 plus 30x. Is there anything I can factor out of the top and bottom? Yeah, I could factor a 2 out of both. And therefore I can cancel those 2's and I'm done. And that is going to be it. Can't simplify any further. Okay, find the domains of the functions. Well, I don't know if you're aware, and hopefully you are, but when you divide something by 0, it doesn't work out very good. You get an error. Okay, so we're not allowed to divide by 0. It just doesn't make sense. Okay. The more you think about it, the more it's like, yeah, this makes sense. So if we're finding the domain for f, because we're, that's part A, that's part B, then you would, actually, I'm just going to do part B only because A is done the same way. You would say, well, the denominator cannot be 0 because you can't divide by 0. So I just write that down. Denominator cannot equal 0. Oh, okay. So if I factor this down, let's see, minus 3 plus 2 right there. Then I would say, oh yeah, when I set that to 0, I'm going to get 3. And when I set that to 0, I'm going to get negative 2. And so that's going to be the domain. The domain is x cannot be 3 or negative 2. It can be anything else. Everything else is fair game. You plug any other number in and it's going to be okay. You plug any other number into this function and everything's going to work out Jim dandy. So on the number line, your domain would look like this. Everything is shaded in except 3 and negative 2. They're the bad guys. They're the ones that make the denominator 0. You're not allowed to divide by 0. If we do this in interval notation, it'll be negative infinity to negative 2, union, negative 2 to 3, union, 3 to infinity. That would be it. Now, lest you don't believe me, let's check it out on the calculator real quick, okay? So, oh, I gotta hit the quit button. Okay, let's go here, and I'm gonna just type in the function. So x plus 2 over x squared minus x minus 6. I think that was what I had for sure. Okay, so if I go to the table and I look around, I'll notice, yeah, you plug in -6, you get an answer. -6 is in the domain. You plug in -4 into the function, you get an answer. -4 is therefore in the domain. Whoa, -2 you plug in, you don't get an answer. -2 is not in the domain. So that's what it means when you get an error message on the table. Oh, 3 is not in the domain. But everything else we're looking at is in the domain. So, I'm feeling pretty comfortable about that. Okay. So that's one way to kind of verify it.